Okay, so for the next 10 minutes, we're going to be talking more about logs. And one of the main things I want you to be able to do is change between the different kind of logs. So here's a log. Log. And first of all, I'd like you to say that properly. Log. Perfectly. Log base 3 of x equals 17. Okay, now I'd like you to write it as an exponential. Stay with me one little step at a time. There's like 10 things I got to show you how to do. You probably know how to do 9 out of the 10. But hey, all it would take is one thing that you pick up in this review. Might save you a point later. All right, so here we go. That would have been 3 to the 17th equals x, right? And what form is that in now? Exponential. And when the calculator is around, you're allowed to use calculators on some of the tests. Would this be a good place to use the calculator? Yes. All right. And if I had asked you to write this in a form that the calculator could do it, would this be a form the calculator could do? Yes, it would. What happens if we have one where the x is here, and then then the kid writes this? Is it a true statement? Yes. Is it something that the calculator can solve? And that's not something the calculator can solve the way it is. No. Okay. What happens if I put the x over here and I have that and I say put it in a form that the calculator can solve? And again, the kid just thinks, well, you always just do the circle of life thing. This to the this equals that. The calculator can't solve that like this. That's not a form the calculator can solve. What can the calculator solve? Log 3 over log 7 would have been the right way to write that. You are correct. Okay. All right. Next topic. Base changes. Let's say we had, there's a property that says if you have like log base 3 of 3 to the 5th, that the answer for that is just what? 5. Done. So sometimes they'll do something like this. They'll replace that with like 27. And then it's really easy if you just change that base. 27 can really be what to the what? 3 to the 3rd, and then automatically you know that this whole thing can be written as what? 3. The answer is just 3. Okay, there's another property that you have to know, and that is that if I have like 10, log base 10 of 2x, that's equal to 10. If you know the right property, this whole thing becomes a snap. What's the stuff in the blue box equal to? 2x. Because if this and this are the same, then that's the answer. I haven't done many of those, but it's a property we've learned. So 2x is what the whole thing is equal to. So then it's 2x equals 10. You just bring this down, and then x equals 5. See how that's easy to solve if you know the right property? This is 10 to the power of log base 10 2x. I'll give you another one like that. 6 to the log base 6 of 15. What's that equal to? 15. That's a property. There's another property you're supposed to know. Log base 3 of 3. What is it? It's 1. And you can either memorize that if these two are the same, the answer is 1, or you can think, what power would be right here? A 1. And so it's just like one of those other properties where if these two are the same, then the answer is there. So the answer to that is 1. Okay. And there's one more thing. Log base 3 of 0. All right, because if I say equals x, then I could say 3 to the x equals 0. And remember, that's the one that you can't ever make work unless this was a base what? If it was base 0, then you could do it. Then that would be equal to what? This would be equal to what? Be 1, just because of definition. All right. Next thing. There's 3 places you can hide the x. Log base x of 5 equals 15, or log base 5 of x equals 15, or log base 5 of 15 equals x. Those are the 3 spots x can be. Let's just go over really quick how to solve each one. And I would just put each one of them into the circle of life, and then one of them may or may not work in that. The other two will. This is x to the 15th equals, and that's one of the ones that can work. What do I have to do to sub both sides? Put it to the 1/15th, you'll be done. This one, 5 to the 15th equals x, and that's easy if you put it in that form. You just grab a calculator and go 5 to the 15th. This one, 5 to the x equals 15, and that's the kind we started with. You can't do that one in your head unless this number can be written with the same base as this number. And since it can't, you have to go to the calculator and go back to this. And what would you put in your calculator? Log 15 over log 5. Anytime you have the x and the exponent, you know that your only two choices are either make a base change or make it so that your calculator is doing the work for you. All right, so let me do one more like that. Log base 5 of 125 equals x. You can do that with a base change. You could rewrite it as 5 to the x equals 125 if you wanted, or you could just rewrite it right off the bat and say, oh, that can be written as 5 to the what? 5 to the third. And then if it's log base 5 to the third, then I can use the property thing and say that that whole box is equal to 3. All right, moving on. There's big, long, nasty kinds of logs that sometimes are hard and sometimes they're easy. Let's say it was negative 30 plus 2 log, and they often don't have parentheses there, so I need to get used to that. Let's say 2 log, that means 2 times, log base 3 of, let's say log base 2 of 8 equals x plus 7. Is this a really hard or really easy one? Why is it easy? It looks hard. It's a lot of parts. It's this part. This part can be replaced because, Max, what's that? That can be changed into to the, and 2 to the third gives you 8, so therefore the bases are the same. Therefore, this whole box can be replaced with what? 3. And so it really just rewrite this whole thing except put a 3 in there. So it's negative 30 plus 2 times 3 equals x plus 7. And it's hard to believe that's supposed to be the easy part, but it is. You guys are so good at solving that from here it's really easy. Okay, and negative 30 plus 6 would be negative 24 equals x plus 7. Add 7 to both sides. Subtract 7 from both sides, and you have negative 31. Is that right? Okay. Now, let's backtrack and say, what if it hadn't been so easy, though? What if this had been a 9 right here? What's the way you can make it easy? Use a calculator. Because then you could just do this on the calculator, right? And what would you get for that part? Log 9 over log 2. Okay, that'd be really easy. All right, so what if it isn't that kind? What if it's got like an x right there? Now we got to solve and get this stuff in the red box here alone. So what's your first step? Everybody write this one down. I want you to actually do this one. When you're engaged, you're going to be doing better than if you're just watching me. So there's my first step. Now I'm going to get rid of the 2. Okay, I'm sensing that I might be in trouble on this one, but I'm going to make the circle of life thing and go x to the x plus 37 over 2 equals 9. That's all correct so far. But now, do you remember when I told you that if you ever have the x and the exponent, there's only 2 ways you can do it? What are the 2 ways you can do it if there's an x and the exponent? Base change. Can we make these bases the same? Calculator. Go back to the calculator and say, well, then I normally go do this part on the calculator. Can I do that part on the calculator? No. So this kind won't work because you've got you've got a variable in the base and a variable in the solution, and you don't have a tool for solving that one. Okay, I'm sure it can be done, but we haven't learned how, that's for sure. All right, that's the hardest kind, and that would be a no solution for you.